This class we shall see about the different interrupts of 8051. Before we go into what is interrupt, before we go into the 8051 interrupts, let me tell you what is an interrupt. So it is some event which stops you from doing the normal work. For example, somebody comes into my class, I stop my class, attend to the person, then come back. So it is similar to that. So when an interrupt occurs, the program has to stop, go find out what is there in that interrupt, finish that program, come back. It is as simple as that. So when it goes to a particular address to do the work of that interrupt, you call it as an interrupt service routine. Fine. These are terms which you need to know as such, because we'll be talking in terms of the technical names. So interrupt service routine is a program which is written when an interrupt occurs, and that program is available in some location. If the location is mentioned, it is called as vectored interrupts. If it's not mentioned and you have to find out the location, you call it as non-vectored. So in 8051, what do we have? We have different types of interrupts. So there are 6 different types. There are software interrupts, hardware interrupts, and all are vectored interrupts. So power on reset is always taken as an interrupt. You can consider, or you need not mention that. Then you have INT0, INT1, which are interrupts which are hardware or external interrupts. External means some signal comes to a particular pin and it causes an interrupt. But when you say software interrupts, those are interrupts which occur because of some software. For example, the timer is overflowing. When it overflows, it will give you an interrupt. When the data arrives in the serial port, it gives an interrupt. So those interrupts we call it as software interrupt. So we have timer 0 interrupt, timer 1 interrupt, and we also have serial interrupt. But the external interrupts or the hardware interrupts are 2. So now what is the difference between interrupt? Is it useful to go on for an interrupt? It is useful because if you don't have an interrupt system, we'll be continually in a polling process. For example, I know that students may come in between, join in between. If I don't work in that interrupt mode, I'll be continuously checking, is a person coming, is a person coming. So what happens? My work gets stopped. I don't take class. I'll just be waiting to see if a person is coming and I'm going to allow him inside. So this that is the main difference between interrupt and polling. So interrupt automatically comes. You don't have to keep waiting. So that is a basic difference. So if you see here, this is an example of how you write a program. So there will be a jump. This J and B is jump, or if there is no bit, that is we are checking for a condition and we are continuously in the same loop. Okay, but when an interrupt occurs, it is like this. Instead of polling, we have the interrupt. So you have 2 blocks. One is interrupt, one is interrupt. This is just to depict what is the use of an interrupt. So if it is in polling, you will be in a while loop. But interrupt, we don't bother at all. When the interrupt occurs, it is serviced. Okay, so what is the process of an interrupt handler? So when an interrupt occurs, the microcontroller should finish its current work, then go to that place and come back. But how is it possible? How can it come back? So the location where it has to come back is always in a program counter. So that address has to be saved now. So we put it into a place called as a stack. Then it will go to that vector location, and the program counter now gets that address of the vector location. So it does all the function over there, finishes it, and again it comes back. So how does it come back to the same location? It comes back on a return on interrupt instruction. So in that interrupt service routine, you should have given an instruction called as RETI. So once it gets that instruction, whatever was inside the stack is popped back to the program counter. So program counter had the address where it stopped its main program. So when it gets back that address, it comes back to the same original address. So this is the flow. So whatever I have explained you, it is depicted in this flow. So here this is an example of an interrupt service routine. That is, when an interrupt occurs, we try to glow the LED. So it is there in the main code, but when an interrupt occurs, it will change the condition, that is, it is complementing the port. If it is high, it will make it low. If it is low, it will make it high. So you can very well try this program in KLC and see how it functions. So now we need to know what is the vector locations. I told you that it is vector. Then which is the location? You have different locations. This is defined. You cannot change the locations. So the different vector locations are given for the different types of interrupts. You have timer 0, timer 1, you have serial, you have the timer 0 and timer 1 are the overflow interrupts. Then hardware interrupts, you have INT1 and INT0. Then you also have the serial interrupt. Okay, so this is the way in which you write your program. So I have given you a lot of examples where you can see how the interrupt works. Now we shall come to the hardware interrupt. So when I say hardware, first thing what you should know is which pin is that hardware point. So we have pin number 12 and 13. They are port pins, but they have alternate function of the interrupt. So it will any signal you connect to this pin, automatically it goes to that interrupt location. So what are the options available in this? So I told you when you connect a signal, it gives an interrupt. But when does it give an interrupt? Is it checking whether the level of that pin is changed, or is it edge triggered? Is it getting a signal from a high to low or a low to high, or it is checking whether the signal has become high or the signal has become low? So that is done by checking for this pin and checking whether it by setting it as level or edge triggered. So this is the diagram of the interrupt structure which is available inside. So we, as I told you, it is edge triggered or level triggered. So when it is level, it is high or low. When it is edge triggered, it will check for that edge, rising edge, or is it a falling edge. But how do you set all this? So for setting it, you have a register called as TCON. TCON is actually meant for timer, but just to enable these two pins as level triggered or edge triggered, you have two pins, IT0 and IT1. So you can set it as edge triggered or level triggered. And also you have a bit to enable the interrupt. If you want to enable the interrupt, then you can also enable it. That is also available here. Other than that, you have a register called as an interrupt enable register. So you have to enable this register, and there are different bits. One bit is to enable all the interrupts. Then you have individual bits to enable the particular register, particular interrupts, either internal, external interrupt, or the timer interrupt, or the serial interrupt. So this is the format of enabling or disabling the interrupt. It is just to give it a set B or clear, because these are all Boolean instructions. So what if two interrupts occur at the same time? So there are priorities. So how is the priority defined? The priority is defined in this sequence. External interrupt 0 has got the highest priority, then timer 0, then external interrupt 1, then timer 1, then serial. Okay, this is the sequence. Suppose you want to change the sequence. That is also possible by this priority register. So if you make one as high and the other one as low, maybe the external interrupt 0 is the highest priority, but you make it 0 and the next one you make it 1, that means that has a higher priority than the previous one. So that is also possible, and this is a format in which you can set the priorities. Okay, so when a high priority interrupt is working, low priority is not accepted. But when a low priority is working, the higher priority register is, the priority interrupt is always acknowledged. Okay, so you can just go through the programs and try it out.